Hi there. We're now going to start taking a look at the Day 2 labs that we've got for the 507 course, and we're going to break these into a couple of different modules because it is actually quite a bit of material to get through in just one go, and we want you to be able to zoom into each individual piece depending on what you're working with at the time. To get started though, for all of the labs that we've got coming up here for this section, we're going to be taking a look at the instructions that are on page 35. The instructions on page 35 are for getting started with rule-based validation and scanning. And the very first thing that they're going to ask you to do is something that's a requirement for all of the labs for this section. We need to get a couple of virtual machines up and running. So previously, we had talked about the need to copy the virtual machines, the 507 systems folder, over onto your computer. We also said that you would need to unpack each of the virtual machines that was in there because they were all zipped up. So you can see here that I've actually already uncompressed the auditor, firewall, and internal systems. And just to prevent confusion, I'm actually going to delete the other 3 zip files. Now, there is still the Unix web server, but we haven't come to that machine yet. We're actually going to use that in the Day 3 exercises and in some of the Day 5 exercises. So we'll just leave that one alone for now. I'd recommend that you not start by beginning with the auditor machine. Unfortunately, when the author of this particular day of the material built these virtual machines, it seems that she sort of maximized the amount of RAM that they would each take, which means that you could very easily run out of RAM before you could ever get that one started up. So what I find works better is to begin maybe with the internal and the firewall. Let me just get those started here. So I'll just double click. Now remember that I am running on a Mac here, so it will look slightly different than what you see in Windows, but we will see all the same messages. And this is the first message you should expect to see. Just like with the ESXi box, it will tell you this machine appears to have been moved or copied. And as we mentioned in the past exercise with ESXi, it really doesn't matter what you pick here, but don't pick cancel because then it won't start up. So I'm going to pick moved. And you can see that DMZ host is starting up. So I'll just move that out of the way and move on to the next machine. I'll also start up the firewall. And the icon that I'm clicking on here, this too will look slightly different on your Windows host. What I'm looking at, or the file I need, is the one that ends in the .vmx extension. Now, you may not see that in your Windows host, because by default it will hide the extensions for known file types. But what you will see are the 2 squares connected to each other. It's that file. It's named Firewall, and simply double-clicking it will open up the virtual machine and get it started. So once again, I'll click I moved or I copied it, and let that virtual machine start up. All right. Now the reason that I started with those rather than auditor, and I had mentioned this matter of the memory and how this can help us, is that when I start the auditor machine, if I do not have enough RAM, it will give me the option of reducing the memory footprint for that virtual machine. Now my workstation does have enough RAM. I've got 16 gigs in here, so I have no problem at all. But if you follow this order and you do get a message about, not enough RAM, should I change it? Click OK, and it will automatically reduce that down for you and run with the memory that you have available. I'll let that one get started as well. We can see that the firewall is starting up, and that one does take a bit longer to start. It's starting up some other services, and it's also trying to do some name resolution, which it's going to find to be quite difficult because these virtual machines are not actually connected to anything that you're going to talk to. Instead, these virtual machines are sort of sitting in their own little world, their own little private network. That way, we can do anything we want with them, any kind of testing, and not worry that we're going to affect other things or potentially unleash an attack against somebody or a scan without intending to. All right, so with these machines up and running, I'm going to close up the 507 systems window, and let me take a look at my directions. So the directions there on 35, we've actually just done the setup piece, which is starting up those virtual machines, which we can now see running. And after that, we have a network map to sort of show you how these systems are laid out. Now, in the diagram there, it shows your laptop as being at 128.226.1.1. This is the diagram that I'm looking at here. Now, we have not actually changed the address of your laptop to be that address, and we're not going to for the lab. The reason is that at no time in the lab do we actually ask any of the virtual machines to talk to your laptop. However, if for some reason you'd like to do some experimentation and you'd like to actually talk to these virtual machines with your computer, then you could go into the VMnet 1 configuration within your network control panel and modify that IP address to match 128.226.1.1. But again, that is absolutely not necessary. I'm not going to do that here because I'm just going to work through the lab. Okay, but it's showing us this diagram so that we understand two things. One is so that we can see the layout of our network, but the other is to put it in the context of the rules that we have listed here. Now this is a very small network diagram, as you can see, but remember, we're dealing with scope. That was one of our big topics we had from the very first lesson. And we're interested in the perimeter, particularly right now, the firewall. So with that in mind, it's given us a pretty simple use case up here. Let's see, firewall has two interfaces. One is at 128.226.1.10, and it has an external interface at, that is its external interface, and an internal interface at 10.17.1.1, and it says that that's on the DMZ, or perhaps a screened network. It says there is one DMZ host located at 10.17.150. All right. Now next, we want to know what the policies are. It says that there should be no traffic permitted from the outside to connect directly to the firewall itself. So that means people on the internet should not be able to connect to the firewall. Now it may appear that they are, because seeing that my internal address is a private address, chances are this is doing port forwarding, or network address translation, NAT. So for instance, someone connecting to that DMZ host would probably be entering the IP address of the firewall, but you see, the connection is not actually terminating at the firewall. The firewall is passing it on. The point of this is, if there is a service running on the firewall, now I notice on the next point, port 22 will be open on the firewall for administration. So for example, port 22 is available on the firewall, but it should not be reachable from the outside. That's a requirement. So we would want to make a note of that. Next, it says the DMZ host is a web server, and therefore packets to port 80 should be allowed through the firewall, but no other services should be allowed to pass through the firewall. It says that no packet should be allowed to leave the web server other than replies to requests. In other words, proper egress filtering. So outbound, this would be a deny all except for responses. That's what we should expect to see. Okay, so there's our policy. We should be allowing inbound port 80, outbound responses. The firewall should be listening on port 22, but only on the inside. Excellent. With that simple policy out of the way, we're ready to move on to page 35, where we actually get started with the lab. So if you'd like to, 36. So if you'd like to follow along in your book, you're welcome to do that, or even follow along and do the lab with me. The very first thing it's asking us to do is to log into the auditor virtual machine. Now, the password, the username and password for the auditor virtual machine are, let me come on over here, our auditor, which is already where we are, and the password of password. No capital letters, no numbers, nothing special, just password. Because really it's just for a lab. Yes, of course, we know it's a bad password. And in the instructions on page 36, it's saying that we're going to need to open up a terminal, a command prompt, in order to be able to do all of our different tests. So let's get one started. I'll just click on the terminal button. There we go. Now, the auditor virtual machine, I'm just going to run the ifconfig command, because that'll let me see the network configuration of this machine. And I can see that its address is at 128.226.1.50. So to orient myself now, let's think back to that network diagram. In fact, let me just put it back on the screen here for a moment. So in that network diagram, we had the DMZ host, the firewall, and, there it is, the auditor machine. So for the purposes of our lab, the auditor machine is outside of the firewall. That's where we're doing our testing in this particular case. Okay, knowing that then, we can now begin to ask some questions. It starts by asking us to use a tool called Nmap in order to see what kind of services might be available. So it starts us off with an Nmap 128.226.1.10. That's going to run against the firewall interface. Although, I'm going to cheat and I'm going to add an option to this. When we covered the Nmap material, I pointed out this particular option, the -n option. What it does is tells Nmap to run against the host with all of its default settings, however, to not try to resolve its name. And the reason I add that in is that this is a completely self-contained network with no name server. So if I tell it to try to resolve names, it's going to take a long time to figure out that there isn't one. So instead, this will short circuit and really speed up some of the things that we're doing. Now, it says here that there were 0 hosts up, but I can see in my other window that the firewall is running. So why might it be that it didn't answer? Well, it could be that there's some basic routing protections or maybe a firewall rule that tells it not to answer. So is there something I can do to see whether or not there are actually ports listening? The answer is yes. The next part of the lab says that we should try to run Nmap again, and I'm going to add in my extra option, the -n, to run it with ping n, which you may find in some versions could also be written as p0 or no ping. So no ping, and we're going to run for ports 1 through 65.535, and we're going to run it against 1.10. Off it goes. So now this is going to take it a few seconds to run, and in the meantime, it's asking us, are there any unauthorized ports accessible on the external interface of the firewall? Now we already know what things should be permitted. We know that port 80 should be permitted. And it's possible that they didn't write it out, but maybe port 443 as well. But nothing else. At least that's what the policy says. So we'll let that run for a couple of seconds. While it does that, I'm going to scroll ahead here. Let's see, so I'm on page 37, step 4, testing the internal interface. So for the internal interface, how could we scan that? Where could we scan it from? Now, if you think about this, the auditor machine really is not the right selection because the auditor machine is sitting outside. So the firewall will interfere with any of the communication. But if I were to switch over, I lost my mouse, there it is. If I were to switch over to the internal host and log in there, and it tells me right on the screen what the password is, auditor and password. I could again just check, where am I? 10.17.150, I'm now on the inside. I could run really the same scan against that internal host. And just for speed's sake, I'm going to run a smaller scan so that the video doesn't turn into a really long video. So I'll just run the first 1,024 ports against 10.17.1.1. Off it goes. So now that's scanning as well. Now, it's going to ask me again if there's any unauthorized ports permitted. And look at that. They both ended at the same time. How about that? It finds in this case that the same port is open on both sides. Is that okay? Well, on the inside, it found port 22. Now, we only scanned a limited number of ports. I can't be absolutely sure that there aren't more open, though I don't really remember there being more open. So port 22. Was that okay on the inside? According to the documentation, that was just fine. But then we find port 22 is listening on the outside as well. Is that okay? Well, no, that's not okay at all. In fact, we could even add an option here. Let's see, we could try to connect to that service, but let's try something else here. Let's try to do, we'll leave the -pn, I'm going to give it -p22, just that port, and I'm going to ask it to do version scanning. And, and of course you have to specify the target, 226.1.10. And it comes back and says, oh, that's an OpenSSH 5.8 P1 Debian. So is it really an SSH server? Yes, it is. It is the SSH server on the firewall. Now that's a finding. because what we saw is that the firewall, it should not be listening on any external ports except perhaps port 80. Now I didn't get an answer on port 80, but there could be other reasons for that. You see, remember, it's a firewall, so seeing that it's not a complete connection, it may not be permitting back responses from the server that's sitting behind it, the DMZ internal host. So that's not a sure finding. But we do know that there's an extra port listening, and that is definitely bad. On the internal interface, we didn't see anything unauthorized, so I think we're okay on that one. I'm now moving on to part 2 of this same lab, so that's on page 38. The next thing is to see what happens when I try to scan through the firewall. Now, scanning through the firewall, we said in class that really Nmap is not the ideal tool for this, because we want something that's going to be very repeatable. It's going to generate packets in exactly the same way every single time it sends them. And the way we were going to do that, we recommended using the tool hping. Now, in the slide in page 38, excuse me, not in the slide, in page 38, it suggests that we use the hping tool to do that. So the hping tool, if we were to simply write the command, saying I want to run an hping, sending maybe a SYN packet, and to run a scan of ports 1 through 100 of the 10.17.1.50, I get a message back saying it can't open a raw socket. There's actually a very important part of that command that I left off. Right now, if you look at my command prompt, it ends in a $sign. Now you may know that if it ends in anything other than a £sign on a Unix machine, then you are not an administrative user. You're not the root user. And that's the problem here. hping requires a raw socket. It wants raw, low-level physical access to that adapter. And only root has that access. So by typing sudo first, now it's going to allow me to run that command as root. I simply type in my password, which is password, and off it goes. And, oh, it's really not happy about something. Let's see what happened there. Let's see. Ooh. Sorry, I can't seem to control my mouse here. Go out this way. Maximize it that way. Memory map. It gave me some kind of problem. Buffer overflow. hping terminated. Okay, so it didn't like something. There's something not right in hping. That's not our problem. But I can see that I actually did get some responses back. All responses received. So I got back non-responding ports. 1, 2, 3, 4, 5, 6, but there are some that seem to have responded. I see that 5, 6, those said not responding, but then 7, 8, 9, oh, there they are, I'm sorry, I skipped a line. 7, 8, 9, 10, 11, 12, 13, 14, on and on and on. So I can see what kind of ports might have been available. Now it is interesting that I'm getting that particular error there. Let me try something just to troubleshoot this. I'm going to just do sudo su, which will make me the root user. And then I'm going to run hping again, -s, and let me see here. How about I bring up the help first, and I just want to specify maybe a starting, or maybe a single port. How about that? So let's do hping -s SYN packet -p, because that's what's used for specifying the destination port, and I'll put port 22, and I'll then put the destination host. All right. And what I was interested in seeing is whether or not I got the same error. I was trying to track down what's causing that problem. So let me try this again. I'll do the -- scan. Let me try port 1 through 10. Oh, and that seems to work correctly. Okay, all of those answered. Let's try -100, and that worked too. Although now I did actually get some things that I could read. I'm wondering why that failed the first time. Let me just try to run it this way again, and whoa, it blows up. So apparently there's something that's changed on this virtual machine, and it really does not want to be run using sudo like that. And in fact, when I do it that way, I'm getting some false reports, because I'm not seeing the ports that were actually open. Now this wasn't expected. I didn't expect to see it that way. Some repair is going to have to be made of this virtual machine. But there is a lesson to be learned here. If you run a command and it doesn't behave as expected, it gives you a weird error like that, in that case, some kind of a crash happening, clearly you need to figure out the cause of that and then try to work to get that error to disappear before you can rely on the results the tool is giving you. So here now, with no error showing up, I can see that it reports that 2 ports answered me. Notice here, it's saying that port 21 and port 80 both sent back SYN-ACK packets. Now I hadn't seen that using Nmap, but now I can see that FTP also appears to be listening on this machine. Now can we test to see whether or not that's true? Absolutely we can. So let's do this. Let's come over here to the internal host. That's the 1017.150 host. And let's start up TCP dump. And that's what it's talking about there on the bottom of page 38. So we'll start up TCP dump. I'll do -I Ethernet 0 -NN. -NN says don't do any kind of resolution. Just show me what shows up. And, oh, I do need to put an SUDO in front of this because in order to run a sniffer, you do need to be the root user. Off it goes. Now, if you happen to be running a Macintosh, you are going to get this message. You won't get this on a Windows host. You will get it on Linux and a Mac. You just need to type in your password here. What's happening is the Mac or VMware is requesting low-level access here, so the Mac is alerting you to that fact and allowing you to interfere with it. Okay, so now that that's up and running, I can see there's actually some traffic because my computer is actually plugged into a live network here. So we'll see if we can weed out as much of that as we can. In fact, I can weed some of that out right now. I'm going to add something in here that you probably will not need to add. I'm going to tell it not net 192.168.2.0 /24. That way, I'll see some broadcast traffic, like I can see some span entry traffic, but I'm not going to see any of the network traffic that's going on inside of my local network. Okay, so with that done, let's come on back over here, and we are going to rerun that HPing scan. And oh, and what happens? Let me come back here, and I'll stop it. When I ran the HPing scan, I can see packets from the outside coming into port 21 and answering back. And here's one coming into port 21, and, well, this one's a reset, so no answer to that one. But then I see another packet to port 80, and I see an answer. So we had a statement that said there should be no direct communication from the outside to the inside except for port 80. And what we're finding is you can go directly in, even using that private address. And you can do it on more than port 80. You can also do it on port 21, possibly even on other ports. All right, so that's how you can work through answering questions like that and seeing what's happening. And the reason we fired up TCP dump is to prove that it actually got through and it wasn't the firewall just giving back a false answer, maybe trying to lead an attacker down the wrong trail. You would want to repeat that kind of activity using UDP next, and that's what it talks about on pages 39 and 40. However, we are not going to do this using UDP. The reason is that UDP is extremely slow. And it would take us probably another half hour or so just to run the UDP scans. In fact, if they were an exercise you were going to skip, I would skip the one that suggests that you do the Nmap-S-U for 1 through 65,535 there on page 39, because that can take you 45 minutes or an hour to complete. The reason being, as you remember from class, that UDP, it will not answer if the port is open, which means it takes a very long time to figure out whether or not there is really a service available. However, the last part of this lab does ask you to also start up Wireshark. So I'm just going to fire that up and show you quickly why that tool is useful, because we don't really use it. Well, actually, you know what? I'm not going to fire it up now, because in a later lab, in today's material, when we do vulnerability assessment, we're actually going to take a look at Wireshark 2, because we're going to look at what the vulnerability scan looks like in Wireshark. So that part on 41 and 42, we'll circle back and we'll do that a little bit later on. However, that'll bring us to the end of the firewall testing section, so we're going to stop the labs here. The next lab, though, will pick up and deal with network mapping.